Energy can be defined as the ability to do work. In other words, the ability to apply a force over a distance. In other words, the ability to move things. There's two types of energy, and those two types of energy are potential energy, which means stored energy, and kinetic energy, which means energy in motion, or energy that's moving. So let's first take a look at the different types of potential energy. Nuclear energy can be thought of as the source of all energy. And the reason that's the case is because nuclear energy can be described from Einstein's famous equation E equals mc squared, where E equals energy, m equals mass, and c is the speed of light. So c squared is the speed of light squared. If you cover up the c squared, you get energy equals mass. This means that if you destroy mass, you actually create energy. And likewise, if you destroyed energy, you could create mass. We can't currently do that, but we can destroy mass to create energy. The way we do this is in nuclear reactions. If you look at that little cluster of red and blue spheres there, that's the nucleus of an atom made out of protons and neutrons. And in nuclear reactions, called nuclear because it deals with the nucleus of the atom, little protons and neutrons can be destroyed, totally destroyed. The mass is gone, and it releases energy equal to their mass times the speed of light squared, which is a huge number. This is the source of all energy. The source of all energy is destroying the mass in the nuclei of atoms. So there's two places that we see this. One of them is nuclear fission, and the other one is nuclear fusion. Nuclear fission is when we destroy mass in the the nuclei of atoms by splitting nucleuses apart. So this happens in nuclear power plants. It happens inside the interior of the Earth. That's what keeps the inside of the Earth hot. It's what powers nuclear aircraft carriers and nuclear submarines. Okay, this is very different from nuclear fusion. Nuclear fusion is a much, much more powerful process. And nuclear fusion happens when you fuse the nuclei of two atoms together, such as two hydrogen atoms, to create a helium atom. And it destroys mass and releases an incredible amount of energy. This is what powers the sun. And this is also what powers hydrogen bombs. It's a process that humans have not learned how to conduct in a controlled manner. So we can't use it for powering things. We can only use it for destruction at this point. But all stars are powered by nuclear fusion, whereas the inside of planets are kept warm by nuclear fission. So there you have two sources of energy stored in the nucleus of atoms. It's called nuclear potential energy. Another type of energy that's stored in a very small level is called chemical potential energy. And chemical potential energy is energy that's stored in the bonds between atoms. So if you look at that picture in the middle there, that's a glucose molecule, and the white circles or spheres are hydrogen atoms, the red ones are oxygen atoms, the black ones are carbon atoms. And you can see there's lines that connect those spheres. Those lines are bonds, and those bonds store energy. When those bonds are broken, energy is released. So that energy that's stored in those bonds is called chemical potential energy. And we experience this in lots of ways. Our food is a type of chemical potential energy. The fuel that we power all of our vehicles with is chemical potential energy. Anything that can be burned is full of chemical potential energy. There's also something called electrical potential energy, and this is the buildup of electrons. And you guys experience this as static electricity. So that kid there's hair is standing up because they have a buildup of electrons. You experience this when you go down a slide maybe, or rub your feet across the carpet. You build up electrical potential energy inside of you. Electrical potential energy is the energy source for lightning. Okay? When you combine these two together, you get electrochemical potential energy. It's a combination of building up electrons by separating things chemically, and that's what you experience and a battery. So storing electricity by separating chemicals. Okay. Next up, we have gravitational potential energy, and maybe this is the easiest to understand. If things are up high, they have the potential to fall down low. So the water at the top of a waterfall has a lot of potential energy, has a potential to fall down the height of that waterfall. The Newton's cradle in that top picture, when you lift up one of those spheres hanging from the strings, you're giving it potential energy due to its higher position. Anything that's up high has gravitational potential energy because it has the potential for gravity to pull it down. Okay. Another one that's a little more complicated is latent heat potential energy. You may come across this more later in your schooling. But anytime that you change phase, such as melting ice, you had to add heat to the ice in order to melt it. Or if you evaporate water, you have to add heat to evaporate that water. And when you add that heat, the heat energy gets stored in the phase change. This is called latent heat potential energy. It's actually what gives hurricanes their incredible power, because all that water that gets evaporated from the ocean to form the storm gets energy stored in it that's then released when the storm powers on through. And then finally, we have elastic potential energy. And this happens whenever anything gets stretched out or compressed, you store energy in it. So a slingshot when it's pulled back, or a rubber band when it's pulled back, or a spring when it's either compressed or stretched out. Even continents. As continents move, the continent itself, like North America, for example, can get stretched out or compressed, and it stores up potential energy that can then be released in an earthquake. So that's all different ways of storing energy or potential energy. Now let's take a look at kinetic energy, or energy in motion. Okay, so let's look at different ways that energy is moving. Okay, one of them is called electromagnetic kinetic energy. And really, this is light, but it goes beyond the light that you're used to seeing, which is visible light. And anything on the electromagnetic spectrum, including X-rays, gamma rays, microwaves, radio waves, infrared light, ultraviolet light, all of those things are electromagnetic energy. And so you experience this all the time. Sunlight is energy traveling from the sun. It's moving, so it's kinetic, to the earth. The heat from a stove is infrared light. You can't see infrared, but you can feel it. So if you hold your hands up by the stove, you feel the heat coming off of it. That is infrared kinetic energy moving from the stove to you. Mechanical kinetic energy is the energy of objects that are moving. So when you're on a roller coaster and you're moving, you have mechanical kinetic energy. A biker going down a hill, a falling rock, a skier, a wrench that's turning. Any physical object that's moving has mechanical kinetic energy. And the energy of it is equal to 1/2 of its mass times its velocity squared. So that's a fun equation to dig into. Another type of moving energy is electrical kinetic energy. We talked about electrical potential energy, where electrons are stored up. Electrical kinetic energy is when electrons are moving. And you experience this with lightning. When you see lightning, that's electrons moving. Current going through a wire is electrons moving. And on a nanoscale, micro processors inside of computers are moving electrons through the little miniature wires inside of them. That's electrical kinetic energy. Sound kinetic energy you're familiar with. Sound travels through anything that has matter can carry sound in it. Okay, and the way that sound travels is it compresses that matter. The speaker icon on the top kind of shows it. As that speaker moves, it sends out these waves pushing out, and they expand and contract the air in front of them. So interestingly, unlike electromagnetic energy, sound cannot travel in space because there is no matter to carry the sound wave. But you guys are used to experiencing sound. A cool thing to do is to put your hand in front of a speaker when the speaker is playing loudly, and you can actually feel the air compressing against your hand. You can actually feel that. That's energy on the move, or kinetic energy by sound. Okay. Thermal kinetic energy is kinetic energy that is um, the result of the motion of molecules, and anything above absolute zero, any matter above absolute zero has molecules that are moving. So those molecules that are moving have heat. That is kinetic energy. Because the molecules are moving, it has kinetic energy. You experience it as heat. You experience it as temperature. When something's hot, you're experiencing the kinetic energy of that substance. Examples: a warm ocean, magma, a cup of tea, heat packs, a fire, anything that's warm has molecules that are moving. That's thermokinetic energy. You can't see it, but you can feel it. Okay, so that's an overview of the types of energy, potential and kinetic energy. Um, Good luck learning more about it. And really, what you want to think about is how energy is transformed from one form to another.